Hello. Today we're going to talk about Topic 5, Section 11, Further Integration. So essentially what we're doing is we're doing the reverse derivative. We're working backwards, okay? Also called the antiderivative. So essentially we're doing the power rule in reverse, okay? So this formula is in your IB formula booklet. The expanded version, so when you have something like this down here, ax plus b to the n, that's not going to be in your IB booklet. You're going to see this throughout this lesson, so make sure you take note of what's not in the IB booklet, okay? Because if you forget this, you're going to mess up your integration, okay? So let's do some basic power rules, or reverse power rules. So here, all we need to do is add 1 to the exponent and then divide by that new exponent. So this would become 5 times x to the 8 over 8. So I get a lot of students that will leave that as the answer. However, once we check it, notice that is not the correct answer. We are missing plus c. Plus c is super, super important. Yep, I'm going to take a minute and I'm going to write super important in red. You should do the same. Super important, okay? Because what this integral is saying is that you want every expression, whenever I take the derivative, I'm going to get what I started with, which was this 5 times x to the 7th, okay? So plus c is a constant. It's any number. It could be plus 1, plus 22, minus 1,000,000, minus pi over 3, plus 2 over e. It can be any number. Okay, because when I take the derivative, it goes away. So the indefinite integral is any variation of this, where c is just any number. Okay, that's what that represents. All right, for the next one, okay, here, this is the expanded version. So we're going to do the same thing. We add 1 to the exponent. We divide by that new exponent. But then also we have 4 times x. Now notice it's inside the parentheses. It's not the 3 outside that we care about, okay? The one on the inside, we take that into consideration and we also put that in the denominator. So when we work this one out, we get 3 times 4x plus 9 to the 4th all over 4 times 4, which is 16. Don't forget the plus c, and check your answer. There we go. All right, and notice we got the same thing. Notice they're written differently, but it's the same answer. Okay, I'll take either way. Now for example 3, do the same thing. What I would do is I would rewrite each of them with an x. Okay, so that 2 would be 2 times x to the 0. Because anything to the 0 is 1, right? We know this. Plus x to the negative 2. And then each one, I add 1 to the exponent and divide by the new exponent, right? 3 halves plus 1 is 5 over 2, right? Add 1 to 0, we get 1. Add 1 to negative 2, we get negative 1. And then we just work this out. So we get 8x to the 3 halves times 2 over 5, right? Keep, change, flip, minus 2x plus, that's x to the negative 1 over negative 1. Okay, so we clean that up. We get 16x to the 3 halves over 5 minus 2x minus 1 over x. Oh, don't forget the plus c, right? And here we go. We've got the same answer. Okay. Now let's do reciprocal functions. So if we have 1 over x, do not treat it like a power rule. 1 over x needs to be changed to natural log. Okay. Notice again, not given in the IB booklet when you have a times x. Okay, so let's do some examples. 1 over x cubed we rewrite as x to the negative 3 plus 1 over x. When we redo that, this negative 3, we add 1, divide by the new exponent, but 1 over x, so this is x to the negative 2 over negative 2, this becomes the natural log of the absolute value of the denominator, so the natural log of x, plus c. You clean it up, you get 1 over 2x squared plus the natural log of absolute value of x plus c. Check your answers. Perfect. Let's do another one. All right. So this is the one where it's special. We've got something times 3 to the x. Okay. So while we still do the natural log of the denominator, we take that into consideration and we divide by whatever we multiply. So this one is literally this answer. Okay. Notice they're written the same way, or written differently, but they're the same answer. Okay, so the natural log of the absolute value of 3x plus 7 all over 3. And don't forget your plus c. I know I'm kind of going through this fast. Hopefully this is making sense. If not, ask me in class. Be happy to talk you through this. Okay, so now exponents. Okay, so again, e to the x is given by e to the x plus c in the IB booklet. When it's special, okay, when you have something multiplying by x, when you have something multiplying by x individually in there, you have to divide by whatever you're multiplying by. That's not in the IB booklet, so be careful. So, indefinite integral of e to the 5x is literally e to the 5x divided by, well, I was multiplying by 5, add c. Bam. They're written differently, but the exact same answer. Okay. Let's do the next one. So it's still going to be e to the negative x over pi plus 1/3, but then we divide by negative 1 over pi plus c. So that's just, keep, change, flip. So we get negative pi times e to the negative x over pi plus 1/3 plus c. We check our answer. Perfect. Don't overthink this, okay? Look at your formula booklet. We are going to get those, okay? So what I recommend is as soon as you get that booklet, when you take your test, write it down, okay? I'll give you those formulas at the beginning of the test. All right, integrals of trig functions, okay? So the integral of sine, opposite is negative cosine. Cosine, it's sine, okay? Again, the abbreviations of anything times times x is going to not be in your booklet, so watch out for that, okay? And always watch your negative sign, so be careful when you do trig functions. Let's do some examples, okay? So, for example 1, we know that the integral of cosine is sine. So this is going to be the same thing as 2 sine 3x plus 1. But then we're multiplying by something on the inside, so we've got to divide that out. And then add your c. Look at our answer. It's the same thing, just written a little differently. Okay? I'll take either answer. They're the same. Example 2. Do each one at a time. The integral of sine is negative cosine. So that's negative 1/2 cosine of 1/3 x divided by 1/3, which is the same thing as multiplying by 3. So if you want, we can go ahead and do that. times cosine 1/3 x. So that's the first part. Okay, the second part, the integral of cosine is sine. So we get -3 sine pi over 2x plus 1.8 all over pi over 2. Keep, change, flip. -6 over pi times sine pi over 2x plus 1.8 plus c. Ooh, almost ran out of room there. Okay, we check our answers, and perfect. All right. Now, integration by substitution. Okay, so this is the technical way to do it.